Hey guys, it's Mrs. Salceda. I'm here to show you how to complete your study guide and give you a little help with that. So we're coming to the end of our physics unit, and you are going to have to ask yourself if you can do these things. So can you calculate speed? Can you look at a graph and be able to identify the distance and the time? Can you explain an object's motion by looking at a graph? Can you explain the difference between balanced and unbalanced forces? And can you calculate net force? So the first question on the study guide says a runner races in a 100-meter dash. It takes her 10 seconds to finish. What is the average speed? So to calculate speed, you need to remember to use your formula, S equals D over T. That's speed equals distance divided by time. You have your distance, it's 100 meters, so 100 m. You also have your time, 10 seconds. So you just need to insert your distance and time into the formula, and then take your distance and divide it by your time. Next question says, what is the distance traveled in the first 5 seconds? So I want you to remember that our distance or displacement is going to be here on the y, and that our time is down here at the x. So we want to know how much distance did this object travel in 5 seconds, the first 5 seconds. So let's start at the bottom at time. We have 0, 1, 2, 3, 4, 5. And then this is at 5 seconds, so we travel up. We'll see where it meets the line. Now we know this is at 5 seconds because we're right over 5, but we want to see how much distance did they travel. So now that I've reached the line, I can move my cursor over to the left to find out the distance, and it falls right here on 5. And it's not just 5, it's going to be 5m for meters, right? So how much distance did it travel in the first 5 seconds? Go ahead and type down your distance. How many meters did it travel? This says, explain an object's motion during line A, B, C, and E. So here at A, I want you to notice that the distance would be remaining the same as time continues on. So this would mean the object's at rest. If the distance isn't changing, but time's moving on, the object isn't moving. You could say stationary, staying still, not moving, at rest. For line B here, we call this a constant speed. You might also see it as a steady speed. But a constant speed is a speed that does not change. Speed that does not change. So this is a constant speed. Line B showing us a constant speed. Line C, we're starting off with a lower slope, but as we continue up line C, the slope starts to get very, very steep. And if you remember, the steeper the slope, the faster the speed, right? So the slope didn't start off being steep, but then it starts getting very steep, and it makes the line curve. So this is what we call an increasing speed. And then E is starting at a distance other than 0, and then it's getting lower and lower on their distance axis, and it's meeting down at 0. And not 0 for time, because time over here would be more than 0, but it's 0 for distance. So at the bottom of this line, drag your cursor all the way to the left, E is going back to 0, which means they're returning to start. So line E here is returning to start. Next, I want you to define force. You have that in your vocab in your notebook, your digital notebook. You also have the definitions of balanced and unbalanced forces in your digital notebook. So use that to define these 3 words. Make sure that you know what they are and the difference. And then number 5 I'll help you with. A box is being pushed 50 newtons to the left and 30 newtons to the right. What is the net force on the object? So one force is working to the left, the other force is working to the right, so they're moving in opposite directions. And I say that opposites always subtract. So this is a subtraction problem. You would take your 50 newtons, subtract your 30 newtons, and that would give you your answer, but then you need to decide, is it going to move to the left or is it going to move to the right? So take the larger force and subtract the smaller force, and then tell me the direction it's going to move and the total net force. So 50N minus 30N, and then tell me which direction it's going to be. If this was two forces working in the same direction, 50N to the left and 30N to the left, and then we would add them together, right? So make sure you know the difference between when you add your forces together when they're working in the same direction versus when you subtract your forces from each other and they work in opposite directions. If you need any more help with your study guide, go ahead and leave a comment, but make sure you feel confident with this material before you take the test.